test I want to show you how we could run. Now, I'm going to show you the t-test, which is basically for comparing means. All right, I want to compare the means of two groups to see if they're different, statistically different. See, the difference between, you guys kind of got an impression of that yesterday when we were looking at your data, and I should compare it. Sorry. I should compare it to, I said Chicatano, she compared it to, that's pretty funny. I compared it to the period ones. And period one's data and your data, the means were virtually the same difference between them. Yet, Nick ran a t-test, and it came out to be insignificant. I think if you would have run one, you would have definitely gotten a significant difference. And here's the reason why. They had such a spread. Their standard deviation was like 3.6 or something like that. Yours was, I think, 0.51. All right, so with that much of a spread, having just a difference of 2 milliliters between the juices didn't make any difference. And he actually ran a t-test. I want to talk about what a t-test does, how you use it. This is a very common test to use if you're doing an experiment and you're trying to find out if what you were looking for actually happened. All right? So it's what's called a post-test only two-group randomized experimental design. All right, that's a big fancy name for basically stuff that you know what you'd be doing. Say, for example, I have a control group. This is the green one here. And I have a treatment group. Okay, I want to see this medicine lower blood pressure. Okay, so I give I have a control group. I give them a placebo. They don't know it. It's a double blind. You don't know it. That means that, believe it or not, you can do that. You simply label them, and then you don't know what you're giving them. It's written down somewhere. There's a key, but you don't know, and they don't know. So when you're reading their results, you're not biased yourself. That's called a double blind. So not only do they not know if they're getting a placebo, you don't even know if they're getting a placebo. All right, but then you got the other group that's getting this drug, and you get an answer at the end, like we got answers for the two juices. All right, and is that significant? Now, it may look like it is, but you have to do a statistical test and find out if those means are different enough, and there are some things that can bother that. There's some things that could actually affect that. You say, well, geez, they're off by so much. It sure looks like they're different. Let's take a look at some of the things that could possibly bother that. Well, first of all, the mean. The further apart the means are, obviously, y'all looking here now, okay, pay attention. The further apart the two means are, the greater chance of this being a statistically significant difference, right? What about the variability? Take a look at those data, all right? This is the one I just had up there a second ago. Here's a guy who has a lot of variability. You see why that would have a lot of variability. This is the spread of the values for the green. That's the spread of the values for the purple. Look at the spread of the values here. Which of those two do you think is more likely to be significantly different? The first one or the second one? Think about it. The first one, not the second one. And, of course, the best one will probably be this guy, right? You see how different they are. All right. Now, this all makes sense. You can look at it in a lot of different ways. It makes sense from a common sense standpoint. You can look at the area under the curve and see how much they share. Think about what that means. This is sharing a medium space there, which means that there's some chance, pretty good chance, not a great chance, that it could be due to chance that these two overlap. This has a huge area where they overlap. And here, there's a very small area. This is kind of what you're looking for, this kind of variability and that kind of a mean difference. But that's the second thing. So how far apart are your means? How much variability you have? And one of the things that affects variability, I wrote in there, is actually the sample size, because that affects how variable it is. All right, so let's take a look. In the end, you're going to read all. I'm going to give you like a few minutes when I'm not done talking here, and I want you to read this over. I actually had to do, in the other class, I had to do it first, but I thought I'd try doing it backwards for your class, giving you the notes, giving you the explanation first, and then letting you read it. Because the three questions you haven't answered on the worksheet all have to, well, not all, but mostly have to do with what we're talking about here. All right, so let's take a look at the equation. I am not going to make you use this equation. All right, I am going to make people who do experiments use this equation in the STEM program. If they do research, they're going to have to justify their results. I don't care if it's just growing plants and seeing which one grew bigger, whatever they're doing. They're going to have to justify it by doing a t-test. This is what the t-test measures. Watch. It's basically a ratio of the signal versus the noise. There's always random error in everything. There's always noise, no matter what you're doing. If I had you go back and just measure with a ruler how long I've done this. I've actually done this for significant figure's sake, just to make sure you're reading it correctly. I have you measure with a ruler the length of a crystal. I had to do that. And then I get the answers. And the answers always vary by a little bit, because your eye is just going to read a little bit. So you're going to get some natural variation. And that's the noise that's in the system. We want to get rid of that. We don't want to include that. That can't affect, we don't want that to affect our results. So there's a signal. Hey, how much of it was due to that drug, I'm giving them that lowered their blood pressure, versus just the noise in the system. So take a look at the ratio. The actual equation looks like this. It's the the difference in the means. So obviously, the larger this value is, right, the more the signal is important, the less the noise is. So whatever makes the numerator bigger or the denominator smaller is going to help you, right? What will make the numerator bigger? Well, the numerator in the equation is this right here. It's the difference between the two means. Obviously, that's a biggie. The variability, all right, if I make that bigger, that's not good, right? Making the denominator bigger is going to make this number smaller, correct? So that's why low variability is better. The smaller the denominator, you all know, the bigger the number's going to be. And that's a good thing. So I broke it down, and this is all in the paper you're about to read. I broke it down to 3 basic factors that really affect your results. By the way, these are not the only factors you would have to include in a study. All right? In a real study, this is how you would analyze it. But what are some other factors that are included in what makes a good study? Well, it's not just these 3 things. For example, I would want to make sure it's a random study. Say I'm trying to figure out the average height of the population of the United States, and I just measured NBA basketball players. I'm not getting a random sample, you see? So that's one of the things. When I want to see if this is affecting blood pressure, I can't just take, I want to see people who already have high blood pressure. Is that what I want to look at? I have to narrow it down to exactly what I'm looking at, okay? So there's other things besides these 3. I don't want you to think these are the only 3, but in analyzing it, these are biggies. Like, for example, the difference between the means, like I just told you. The larger the difference, the more significance. The variability of the data. Now, here is the exact opposite, right? The larger the variability, the worse, the less significance it's going to have. Okay? And finally, the sample size. And the sample size, the reason I say that one in there, even though it's not technically, you don't see it right there, it does show up. The sample size is actually, if you look at this equation, here's the final formula of the equation, which you're not going to have to use. Variability is in there. Remember what makes variability. All right, well, I want to make this number smaller. The denominator, I want it to be smaller. The bigger the sample size, what happens? You see what I'm saying? It's going to make it smaller. And that's good. The smaller the denominator, the bigger the fraction. All right, so the larger sample size. If I'm going to do a study, I use this as an example in your class that came out, I think it was a good one. Remember what we're going for here. I'm about to tell you, I'm done talking here. I'll probably pause it. I'll pause it. And then I'll let you guys read that little thing over there, maybe answer some of the questions. But I have one more thing I want to talk about, and that's going to be the effect of statistics on people misusing them. And there's a lot of ways statistics can be misused. So one of the things I was going to tell you, one of the things that's going to show up in one of the videos we're going to watch, in EMFs, or not EMFs, breast cancer. That's right. It was breast cancer, I think it was. This one study showed that a 200% increase in male breast cancer among these power line workers. You know how many cases that was? 2. Because male breast cancer is pretty rare. So basically, it was an extremely small group of people. They didn't study a lot of people, and you're only talking about 2 actual cases. It's hard to draw a lot of conclusions from that. All right. That's why the sample size has to be large, relatively large. If you're doing a study, you want it to mean something. All right. Let me pause it here and let you read this and answer some of the questions, okay? Because I need to talk to you about a few things and things. I'll give you about 15 minutes, and then we'll come back and we'll tape again the effect of statistics. We're going to have, on how you can misuse